Hello all, welcome to our project IPL Cricket Score Predictor. So now this is a very interesting project as because this is a very interesting topic to touch, right? So the main aim of this project is to build a model which will predict us the final score of an IPL match. This will be done with the help of certain machine learning models and we'll be using the auto machine learning library, that is the TPOT, in this project. So let us first have a brief motivation of or a discussion about the topic. What is our topic? So as you all know, what is IPL, right? Indian Premier League. In the midst of this pandemic, as you know, the pandemic was going on. The IPL has stuck us entertained and hooked onto our seats. That was a biggest entertainer for many of us. I myself, being an avid fan of the tournament and sport, decided to try my hands on a dataset to predict the run score. So basically, there was a data set present in which various information, or I'll be telling you what the data set is in the next section. But let us have a brief review that in that various information of the match is given, and then with the help of that, we can predict the final score of the match, right? How good is that? How exciting is that? So it would be very exciting to work on a data set which gives us the insight of the data of different matches, right? There are different numerous amounts of rows and columns which tells us, okay, what happened in that match. So now moving on, what will we do? So we'll be building a machine learning model which will help us to predict the total run scored, as I have said earlier. So about the data set, we have a data set in which several IPL matches data from year 2007 to 2008 is given. Okay, and information of each ball, every ball of in a match is given in that data set in the form of a row. So we have ample amount of information about that match. Okay, what ball was played, how it was played, how much runs was scored, and everything. Okay, so what we'll be doing, we'll be using different machine learning models and auto ML model for this project. So you must have heard about the machine learning models and all of the different things, but what new to our topic is auto machine learning. So discussing about it, what auto ML is, basically automated machine learning, also referred to as automated ML or auto ML, is the process of automating the time consuming iterative task of machine learning development. Basically, sorry, basically what happens is automated machine learning is an automation which does all the model building and hypertuning part, which is done by the data scientist. If you don't have a prior knowledge of machine learning or a very good knowledge of machine learning, you can use these libraries to do all the things which a data scientist do in the model deployment part, a model sorry model building and hypertuning part. These libraries are also used by the data scientists to consume time or to make their work easier. So the AutoML library which we will be using in this project is a TPOT library. TPOT is a Python automated machine learning tool that optimizes machine learning pipelines using genetic programming, sorry. So what genetic programming is? Genetic programming works on the same way like a how human brain works. That's right. It is based on that only. So TPOT uses a tree-based structure to represent a model pipeline for a predictive modeling problem, including the data preparation and modeling algorithms and model hyperparameters. So basically, this was a working that how TPOT library works. Basically, it uses a tree-based structure in which it creates different pipelines. Okay, different model pipelines. It tells us, okay, which pipeline is the best pipeline, and then we can deploy or we can use that model for our future use. So moving on, what will be the timeline of our project? So the first and the foremost thing will be the data analysis part. In this, we'll be finding out different relations in the data. We'll be checking out. There is not much in the part of data visualization in this project because there is nothing much to do in a data set. Right? You will be seeing how a data set is in the next section, and I'll be telling you what data analysis part we can do, and we'll be doing feature engineering. That means all the one hot encoding and label encoding and clearing out missing values or handling then values, and all of the other things. These all comes in our feature engineering and data cleaning part. Okay, then we'll be building our model using the machine learning. We'll be doing hyperparameter. We'll be using tools like grid search cv, randomized search cv in our machine learning models to optimize them. Then finally, we'll be checking out what is TPOT library, and then we'll be building our model with the help of that. So this will be a very interesting project. So let's begin. Hello all, welcome to our project notebook, that is the IPL score prediction using machine learning and automated machine learning library, that is the TPOT. So now in the introduction video I have told you that okay, which library will be used and what is the motivation behind this project. So now in this section we'll be seeing that how we can develop this project, and I'll be telling you all the code and the different things required to make this project. So now as written in this project, we'll try to predict the final score of a match if sufficient conditions are given. So now as we know, IPL is one of the biggest flex when it comes to cricket all over the world. So it would be very interesting to work on a data set which gives us the insight and the data of different matches. So now as I said in the introduction part, this is the same thing written. So now what we'll be doing all the data cleaning techniques and analyzing our data, then finally predicting our results, then comparing different models, and then we'll be using automated machine library for the same, that is the TPO. Let us have a look at the timeline of a project, right? The main timeline and how a notebook will go. First, we'll be importing libraries and data set. Then we'll be doing the data analysis and cleaning part, that you'll see what all the things are included in it. This it differs in every project, right? Data analysis cleaning part depends on the data, and it differs for every project. Then we'll be doing the data pre-processing. In this, several techniques are same for all the projects, like standardizing our data, handling categorical variables and null values. The process is all the same, only the data changes. But the data analysis and feature engineering part or data cleaning part changes for every project, right? Based on the needs and what all the things are required. So now then finally we'll be building our model, machine learning model using, no, we'll be building the model using ML techniques, and then we'll be using the automated library. So now first importing libraries. So the very first library which we will be importing are the pandas, the numpy, seaborn and matplotlib. The pandas, numpy are for data analysis technique, or pandas is basically the backbone of all of the commands are done with the help of pandas. Every function is done with the help of pandas. NumPy is for computational purposes like the calculation part. Seaborn is for matplotlib, and Seaborn is for visualization part. All the advanced visualization techniques are present in Seaborn, and the basic techniques are in the matplotlib. So now we have to import our data, right? We have to read our data. So now, as we are working in a Google Colab environment, so the Google Colab has its own way of reading data. So there are certain steps. The very first step what you have to do is you have to make a Google Drive. If good you have one, then what you have to do, you just have to first upload your data, upload your CSV file in that Google Drive, from which you have to read, right? So you have to upload that file in your Google Drive. Then what you have to do, you have to go to this section. Then there is a section called Mount Drive. You have to mount your drive in the Google Collaborator. When you will click here, as you know, this particular command appears. You just have to execute it. The command appeared automatically when I click there, right? It is giving me a link. When I click here, basically it will redirect me to all the accounts which are present in my live which are present in my browser. Then I have to select one in which my file I have uploaded, in which account I have uploaded my file. Then I'll just I have to authorize it. Then it will give me an authorization link. I just have to copy it, and then I'll paste it. As it is written, enter your authorization code. I'll paste it here. Then I'll click on enter. It will mount. What it will do, it will mount my drive into my Google Colab environment. This is how you can mount your drive. This is how you have to read your data set, right? Okay, my authorization code is entered. I just have to paste that code and write enter. It will execute for a few seconds. Then it will say that okay, your drive is mounted. It is okay. As you can see, you're mounted at content, not drive. Now, when I see here, first only sample data was there. Now I am seeing drive also. When I'll go to drive, then I'll go to my drive. So these are all the different files which are present in my drive. Okay. So now what I want, my file name is IPL CSV. I have already uploaded it. Here is my file. I'll just copy the path. I'll copy the path and I'll just paste it here. Instead of the name, I'll just paste the whole path. Then I'll just read it. The reading command is the direct. Okay, I have not defined it. Now, I'll just read it. Okay, the reading command is similar like the pd.read csv, only I have to provide the path. When I'll read, then I'll see my data set. So this is my data set. Okay, these are all the different columns and the rows which are present. If this is my head, if I'll be giving you df.tail, it will be telling me that okay, the last lines of the code. As you can see, there are 76,000 rows, right? There are 76,000 rows which are telling me all the each and every information about my match. So this was a introduction about how you can import your data libraries and the data set in your Google Colab environment. So now in the next section, in the data analysis and cleaning section, we will understand okay how we can we will understand the data, and then we'll see what all the different techniques we can perform on our data. Hello all, welcome to the next section of the project. So in this section, we'll be doing the data analysis and cleaning of our data. So before we proceed, let us have a brief understanding of our data. So this is our data set in which various columns are given. Okay, as you can see, as we saw earlier in the previous section, there were around 70,000 rows. So this is a pretty large data set, and now these are the different columns. What does these columns means? Like the as you can see, there are 15 columns. The mid is the match id, uniquely identify each match. Then date is the date on which match was held. Venue is the name of the stadium. Bat team, the batting team. Bowl team is the bowling team. Batsman, the name of the batsman. Bowler is the name of the bowler. Runs, the total runs scored till that over. Okay, which means that okay, if that is the if there are two balls, okay, there are two balls in the second row, it means that there are two balls done, then there are around total of one run scored. So this is what the runs means. And the wickets taken till now. Overs, the number of overs bowled. Then the run last five is the number of runs scored in last 5 overs. Wicket last five is the number of wickets taken in last 5 overs. Then striker is the name of batsman and the batting end. Non-striker, the name of batsman at the bowling end. Total is our dependent variable which we have to predict, that is the total number of runs scored in a match. So now what we do, that first, the very first thing what we'll be doing is we'll be removing some unwanted columns which does not or which does not contribute to tell us the fact that which team is winning. Like the first is the mid, that which is the match ID, we don't need it. And the venue, the batsman name, the bowler name, the striker name, non-striker name, we don't want these, right? Where they we don't want these play no significance at all to say that okay, which team will win. Okay, the name of the venue or the match ID or the bowler name does not play any significance, right? So we'll drop them, then we'll see our data set. So now as you can see, our data set is bit shortened, and this is how our data set look like. We'll be doing several other things for this. So now what we have to do, we'll see that how many different teams are there, right? How many, we'll just do that for the batting team, because the bowling team will also be the same. So now as you can see, there are around 10 to 12 teams, the total teams in that. So what we will do, we'll select some of the teams for our data set. So some of the popular teams which we know that which are consistent and which performs well and which are consistent from all over the years, that okay, these teams are there. What happens in IPL is that some of the teams like the Gujarat Lions or the Rising Pune Super Giants, these teams get changed. Okay, these teams have been changed, we have seen in years. So what we'll do, we'll select some of the teams which are consistent, so that our model will work for all over the for all years, not only for this respective year. So we have selected the teams like Kolkata Knight Riders, Chennai Super Kings, Rajasthan Royals, Mumbai Indians, Kings 11 Punjab, Royal Challenger Bangalore, Delhi Daredevils, and Sunrisers Hyderabad. So now these are some of the teams which are present in at almost every season of the IPL. Okay, so now what we'll do, we'll just keep these teams in a select inner batting team and bowling team. What I did, I just said that okay, DF is equals to DF bat team is in selected teams. The same for the bowling team. So what it will do, it will remove all those teams which is not in this list. Okay, which is not in this list. So now the again one thing what we have to do is that we'll remove the first 5 overs, because as you can see in a match, the very first 5 overs never decide. You cannot tell after seeing the first over, okay, which will win the match. So everything happens in the next 15 overs. Okay, the main thing, the table turns in the next overs. So you cannot basic really tell that okay what will happen in the match, who will win or lose from the very first 5 overs. So in order to reduce the data set, reduce the size of the data set and all the extra information, we'll just remove or the information which is present in our which is present in our 5 overs. Okay, we'll remove all those rows which are less than 5 overs. So then we'll see our head. So then you'll see that our head is starting from the position 32, which is the over starting from a 5.1. Okay, this is the batting team, this is the bowling team. So we have removed all of the things in which the over were less than 5. So now what we'll do, we'll just see okay, what are the unique teams in our batting and bowling team. These are the same. The batting teams are these things and the bowling teams are these teams. These are we have taken from the selected teams. Now the last thing we have to do in our data cleaning part is to change this date variable. Currently this date is in, if we'll see a data type df dot d types df.d types. So now what it has, this is an object type. Okay, we don't want this, we have to change it. So what we'll do, we'll change it into a date time object. So what we'll do, from date time import date time, we'll say okay, apply lambda is just a basic Python function which allows you to write a simple line of function in that one single line of code. You don't have to define that function. What I'll do, date time dot strip time. What this command will do, it will convert that object date into the date, into a date time object, right, into a date time object. So now when I'll see, okay, as you can see, date is turned into date time object. So this is what we did. This will be helpful in our next section, in our training and testing sessions. So now let us have a final look at our data set. So this is how a data set looks like. So we have done all the data cleaning part which we needed. So now there is not much to do in the data visualization techniques because there is not much significant. We just have to do the data cleaning and data pre-processing part in this project. And then we'll in the, so this was the data cleaning part. In the next section we'll see that how we can process the data, what all the techniques we'll be using. Then we'll be modeling our model with different algorithms. Then we'll be using the automated machine learning, that is the TPOT AutoML library. So we have the date which is in the date time format, we have the batting team, we have the bowling team, we have the runs scored till that ball, we have the wickets taken till that ball, the total overs done, the runs scored in last 5 overs, wickets taken in last 5 overs, and finally the total score of that match. So these are all the information which are sufficient to predict okay what will be the score of that match. So in the next section we'll be doing the data processing technique. This is all for this section. Hello all, welcome to the next section of the project, that is the data pre-processing part. So now in this section we will be doing the pre-processing, that is we will be doing the one hot encoding, standardizing our data, splitting our data, basically preparing our data to feed our model. So now the very first thing which I'll be doing in this session is the one hot encoding for our categorical variables, that is the best team and bowling team, batting team and bowling team. In this different teams are there, we have to do the categorical variable. So now what we have to do, at we have two things. Okay, one we have label encoder and the another one we have one hot encoding. So we can also do the label encoding part. What label encoding does is you just have to import that from SQL and you just have to apply it to that to your model. So it will be doing the label encoding. What it does, that in label encoding it will assign you a label. Okay, it will assign you a label, which means that the one number is assigned for KKR, the two number is assigned for RCB, the third number is assigned for Sunrisers Hyderabad, like that. Okay, a particular label is assigned. So now we can do that, but there is one more thing which is known as one hot encoding. I hope you all know that. I'll just give a brief introduction on it. So now one hot encoding is basically done to improve the accuracy, to understand, to make our model understand more of our data. So now what one hot encoding, it creates many different dummies. What dummies means that when I'll execute it, I'll just say pd dot get dummies. I'm giving my data from my df and I'm telling my columns bat team and bowling team. Okay, take these dummies. When I'll see, so as you can see, there will be different dummies created, right? As you can see, the first is the bat team. Every column, there will be different columns created: 1, 2, 3, 4, 5, and 6, and 7, and 8. Okay, as you can see, there are 8 unit teams, so 8 different columns are created, and for similarly 8 different bowling columns are created. So now what happens is, it creates dummies which says, for the column, for this column, bat team Chennai Super Kings. So now, in wherever the row, in which row this the team is of this the row is of this team, there will be a 1, otherwise it will be a 0. For in this case, the team is the batting team is the Kolkata Knight Rider. That is why there is 1, and rest of all there is 0, right? Now similarly in the bowling section, the team is Royal Challengers Bangalore. That's why there is 1, and the rest of all there is 0. So this is what the one hot encoding means. Okay, we have created different columns in which there will be a 0, either 0 or 1, based on the value. So now please remember, one hot encoding is only done when you have not much categories. Suppose if you have around 15 teams, so there will be different 15 columns will be created. So many there will this will lead to 15 bat columns and 15 bowling columns, a total of 30 columns. So which is a little bad for our model, because it could lead to curse of dimensionality. You can Google it, what curse of dimensionality is. It happens when our data set has many number of columns. A model gets confused, or a model does not perform better in that case. So if you can perform one hot encoding if you have less number of categories. Like in this case we have only 8, so 8 different columns were created. So now we can see the different column names. What are the different column names? So this is the different columns, say date, runs, wickets, over, and all the different one hot encoding columns that were created. So now in order to be, this does not looks in order, right? So the runs and the totals should be last. Okay, it should be last. So what we do, we'll just rearrange our columns in our desired format. We'll say the first display date, then display all the different one hot encoding columns, bat team and all the bowling team. Then display me overs, runs, wickets, run class 5, then the total. Okay, this is how it should we have modeled it. Yeah, we have just modeled it. So now if we see our model df, I have named it model df. Okay, you can name it any of the thing you want. So now this is our data set. We have the date, and then we have all the one hot encoding columns, and then the final columns. So now what we have to, we can also standardize this data. Okay, but there are not much variation. Standardization is required when your data is in large numbers. Okay, the numeric value is ranging from 0 to 1000 or 10,000, then the standardization is required. But as you can see, our data is not that big range, so we don't require standardization or min-max scaling here. So now the next thing we have to do, we have to split our data. So now there are different techniques of splitting our data. The very common technique is using the function train test split from sklearn library. So now what that function does, it randomly picks up your data and splits it into the desired format. Suppose if I provided the 30% for test data and 70% for train data, so it will split it randomly, take 70% of data, put it into your train size, and took 30% of random data, put it into a test size. But we cannot do that here, but that is not favorable here, because as you can see, in problems like these, this is dependent on your over, right? You cannot randomly select it. As you can, the similarly in the case of like a forecasting a stock price or forecasting a petrol price, they are dependent on each other row. Here also, my every another ball is dependent on the previous ball. If I'll randomly select my data, so it will create a blunder, right? So what I'll do, I'll just select. Okay, for train data, I'll first simply drop my total column, because I don't want that in my train X column. Okay, independent variable, I don't want that. So I'll just say, okay, drop total, and then I'll say, okay, give me those values in which the year is equal to or less than 2016. So I am taking my train data of all the things in which the year is of the 2016 and less year. Okay, and in the test data I am taking all my greater than a 2017 rows. Okay, so this is how I have split it. So obviously my the data of data is of data for 2016 and less is more than the 2017 part. So I have taken that as my train data, and 2017 year data I have taken as my test data. So I have both dropped the total column from that, and the Y train I have taken the same, only I have taken the total columns, right? I have only taken the total column from in the X train I have dropped the total, and in the Y train and Y test I have taken the total column. So now this is where we required the date, right? We changed our date into a date frame object, so that our model we can recognize, okay, what is the year and what is the month and what is the day, so that we can separate it. So now we don't require our date column, so we'll just drop it from our train and test data. We'll just drop it from our train and test data. Okay, I have to define it, of course. Now we'll just drop it. So now our X train and Y train are totally ready. Now if you want to see how our train data looks like, so this is my train data in which all the my date is not present, my price is not present, only my one hot encoded variables are present, all the different rest of the things are present, in which the information below 5 over is not present, and the data of 2016 and the less year is present. The same is for my test data. If I'll see my test data, so this is my test data. As you can see, the last row is this is displaying my the lastest row. This is how my test data is selected with the one hot encoding variables and all the different columns. So now this was our data pre-processing part. Now our data is completely ready to fit our model. In the next section, we'll be building machine learning models with the different algorithms. I'll be showing you how, and then we'll be using the automated machine learning. Hello all, welcome to our next section of the project, that is the most important, the model building section using machine learning algorithms. So now in this section we'll be building different machine learning models with the different algorithms written, and we'll be seeing that okay, what are our predictions and what is our accuracy. So now the two models which we'll be using are lasso regression and the random forest regression. So now the first regression model which we'll be using is the lasso regression. So now lasso regression is a kind of regression model you have. I know you might have heard about linear regression, multiple regression. Lasso regression is also the same sort. Now if you Google lasso regression, you will get that lasso regression is a regularization technique. It is used over regression methods for a more accurate prediction. How can you provide more accurate prediction? Because what happens in lasso regression, it performs both variable selection and regularization in order to enhance the prediction accuracy and interpretability of the resulting statistical model. In the linear regression, the regularization is not performed. So the lasso regression has an edge over other regression models like the linear and the multiple regression models. So now moving on, first what we'll do, as you can see, lasso is also present in the SQL or linear model library. All the regression model, may it be linear regression, multiple regression, polynomial regression, every other model is present in SQL and linear model library. So we'll just import from there. Then we'll be using grid search CV for our hypertuning part. So now what we'll be doing in this, we'll be hypertuning a model. For that we'll be using grid search CV. In this section I have used the grid search CV. In the next model I have used the randomized search CV. So now, but what is the problem? What is the difference here, right? What is the difference? So now the difference is that in a grid search CV model, it takes data in the form of grid. It has a predefined, okay, you have to take the data from this grid and you will select it and you will model it and find out the best parameter. Now what happens in randomized search CV, it takes data randomly in different folds. Okay, it takes data randomly in different folds and see, okay, which data performs better, and then give us the result. Randomized search CV is more accurate but is not preferred in large data set, as it will take a lot of time because the more data will be taken. So now in this lasso regression we have taken the grid search CV. So now what I've done, I've defined my model, and I've defined the different parameters that define different alphas. Okay, different alphas which is used in the lasso regression. I am saying, okay, I am defining my grid search CV model. I am then fitting my model with this. I am fitting my model in my trained data. Then I'll be seeing, okay, tell me what are the best parameters for this. Okay, as you see, it is getting fitted. Sorry. I have taken the scoring as negative mean square error. That means that give me the ranking, or give me the best parameter who is having the best negative mean squared error. Okay, so now as you can see, my model is fitted. Then I'll see, okay, which is my best parameters. So the my best alpha is 1. So I'll just fit my model with my best alpha, fit my model, and I'll predict my results. As you can see, my model is fitted with alpha is equals to 1, then fit intercept true, max iteration 1000, and all the different parameters. I predicted, I stored my results in IPRID. If I want to see what are my predictions, I can just see them. So this is my score. This is my score in the form of an array. Now what I want to see, I want to evaluate. So what I'll do, I'll choose a very logical and simple method. I'll plot a distribution plot between my original test values and my prediction values. So if my distribution plot lies within the limits of 0 and closer to 0, that means my model is predicted correctly, because obviously if the difference in 0, that means my predicted value and the another true value are true, are equal, right? So as you can see, my model is somewhere more of the in between 0 and somewhere between minus 20 to 20, which is a good sign. That means my model is predicted correctly. Now if I want to see my evaluation in numbers, I can find out, okay, what is my MAE, what is my mean square error, what is my RMSE. So as you can see, these are also quite good. So this was my lasso regression, that okay, now I saw that how my lasso performed. Now the next model which we have is a random forest regressor. I hope you are all familiar with the random forest regressor. Random forest regression ensemble technique, okay, is an ensemble technique of decision tree. What it takes different decision trees, okay, it takes different decision trees, and then find out on the base of the different parameters like the Gini impurity and all the other things, and find out the best optimum results. So now what I'll do, I'll just, these all models are present under the library sklearn.ensemble. I'll import it from here. I'll define my model. Now, as I have said, I'll be using randomized search CV in this. So I have I've imported randomized search CV. Then I am defining my parameters. I am taking estimators from 200 to 800. Okay, 200, 400, 600, and 800. Start to stop till num4. I am taking, okay, this is a command np to line step. It will divide it into 4 parts between 200 to 400. Then I'm saying that max features are my auto and squared, then max depth, then I'm saying minimum sample slip, minimum sample leave slip, bootstrap true and false. These are all the basic parameters which I have taken from net. Then what I have done, I have just stored them into a random grid parameter. Okay, I've just stored them into a random grid in which different dictionaries are there, the different estimators. Basically, I've stored them in a dictionary. Now, what I did, I defined my randomized search CV model. So I have given the estimator as RF. I have given parameter distribution is my random grid. Take it, and I have given n number of iteration is 10, cross validation 2, verbose 1, random state, any state you can take, number of jobs minus 1. So now, and then I have fitted my model. So now this will also take some time, because this is a randomized search CV model. Randomized search CV, as I have told you, it takes time. So on this, for the sake of, okay, do it gets fitted in a less time, I have taken number of iteration at 10, because, but in order for greater accuracy, in order for better accuracy, you can take number of iterators hundreds, okay, 100 or thousands, okay. Maybe take number of iterations at 100 and CV at 5, cross validation 5, and number of jobs also you can change. So this will be the best thing, though this that will be the best for our model to get fitted, but it will take large amount of time. Basically, it will take around 20 to 25 minutes to get fitted on all, because we saw that our data is having around 65 to 70,000 rows, right? So it is a pretty big data set. So it will take a large amount of time to get fitted. So as you can see, with only the 10 iterations only, it is taking so much time. So now after it gets fitted, we'll see that, okay, how much time it will take after it gets fitted. Okay, my is this disconnected, sorry for 1 second. The internet connection was lost. So now it is again fitting it. So now after it gets fitted, I will see that okay, what is our best parameters. We'll see that, then I will predict it. We will predict it, the results. Then we'll do the same. We'll do the same. Okay, what is my mean square error, what is my RMSE, what is my MSE. So this is how you get, this is how we predict it, right? So now in the next section, so this was all about the randomized search CV. Now it is taking some time. It is taking some time because of the randomized search CV model. But you have to do the same. It will be the same thing. How what I did in the lasso regression. You'll just predict it. Then you find out the best parameter. You'll predict the results with with those parameters. You will plot your distribution plot and scatter plot on the base of these. So this was how you can fit your model with the basic ML techniques. We use two different models. Now in the next section we'll be using the automated machine learning, that is the TPOT library. I'll be telling you what TPOT library is on all the other functions in the next section. Hello all, welcome to a final section of the project, that is the using automated machine learning. So now before we proceed, let us have a look at what is automated machine learning. As I have told you in the introduction part also, automated machine learning, also referred to as ML or automated ML, is the process of automating the time consuming iterative task of machine learning model development. So now what all we did in the previous section was model development. So we'll cut all that hustle with the help of AutoML. Now in this section we'll be seeing how do we do that. So now we'll be using the TPOT AutoML. What TPOT AutoML is? TPOT is a Python automated machine learning tool that optimizes machine learning pipelines using genetic programming. So now TPOT is a very popular library. Now if you will search what is TPOT library, TPOT library, this is their official website, and they have given everything. Okay, they are giving everything. They have given examples, and they are using how to use TPOT and TPOT with code, what to expect with AutoML software, everything. Okay, how to do feature selection, how to do pipeline catching. Then we have they have given TPOT API. You can also do the you can even do the neural network part from TPI, neural networks in TPOT. Okay, everything is there. Okay, TPOT, telling TPOT to build using PyTorch neural network models. Okay, everything is there in that is TPOT library. I'll be telling you how you can do that, how can use some of the commands for the machine learning part. So now the very first thing you have to do, you have to install TPOT. You have to install TPOT, and if you are using your common Jupyter environment or Google Colab environment, you can use the command pip install TPOT with an exclamation mark. It will install your library. It will install the TPOT in your particular notebook only. You can also install it in your machine from command prompt. It is the same. Okay, it works the same. So now it is saying requirement already satisfied because I have already installed some of the TPOT library. So that is why it is saying that. Now in the next section what you have to do is you have to import TPOT. Okay, you have to import TPOT, and I am printing my what version TPOT is. Okay, this is my version. TPOT version is 0.11.7. This is my TPOT version. I have imported my TPOT library. Then I'll say okay, this is a regression problem. If this would have been a classification problem, I would have imported from TPOT import TPOT classifier. But as we see, this is a regression problem. I am seeing from TPOT import TPOT regression. So what this will do, it will basically import all the libraries which comes under regression, or all the libraries which we have used in the previous sections. So now what we do, we'll be using the same data. Okay, we'll be using the same train and test data. There will be no change in that. Because we have all the feature engineered data, that is where that we have. Remember, you have to perform feature engineering on your own, even though you have automated machine learning, because the automated ML cannot understand okay what feature is beneficial for you. That is done to be a that job is to be done by a domain knowledgeable person. So you have to do the data feature engineering on your own, and that data pre-processing also done by TPOT. But if you do it on your own, that is no harm. So now what we'll do first, we'll be defining the method for evaluating models. Okay, we'll be importing repeated k-fold. Okay, from model selection we'll be importing repeated k-fold. We'll be defining 10 splits. Okay, what this will do, it will be splitting our data into 10 times. It will be checking or validating our model based on that. Okay, I am taking my 10 folds. Okay, this is a thing to improve the accuracy of the model. Okay, that's why we have taken defined the CV. Then we'll define our model, and I'll be saying model. Okay, and I'll be saying okay, TPOT regressor, this is the model. Then I'm saying generation is equals to 5 and population size is equals to 50. Okay, then I'm saying scoring is negative mean absolute error, because, which means that I am giving the parameter or I am giving the objective is negative mean absolute error, which will what it will do, it will provide the best model based on that. Okay, it will provide me, okay, which is having the best negative mean absolute error, provide me that model. Then I'm providing the CV for that is equals to the k fold which I have defined. Then I'm defining my verbosity and random state. Okay, this is how I have defined my model. Then I have just fit my model. So now in fitting my model, it might take some time. As you can see, it will take some time. So from 0 to percent 0% it will go to 100%. Then what we'll do, we'll just print our results. We'll say model dot score. Then we'll do all the other things also. We'll see that okay, the best what is the best pipeline, all the other things. But right now it will get fitted. So by the time it gets fitted, we'll be seeing all the different things. Okay, so now I'll be telling you what all the other things what we can do after that, how we can evaluate our model, how we can check the accuracy in the next section after this model is fitted, because it will take some time. It will take around 10 to 20 minutes to get fitted. You can check this on your own machine also. Hello all. Now welcome to our final section of this project part 2. In the previous section, as we saw that we were fitting a TPOT model, we have imported the TPOT regression model, we have installed the TPOT successfully. Now it was taking so much time, so I paused the video for a few times and then I said that we'll be continuing in the next section. So now what I did is I reduced some generation and the population size in order to make the time less consumable. So now it is giving me the best pipeline as extra tree regressor, that is this, and all the parameters are given. Now what I'll do, I'll just print my model score. As you can see, this is my model score, and what score is this? This is my negative mean absolute error. Okay, this is my negative mean absolute error because I did the scoring as this. So now what I can do, that I can find my best pipeline. Okay, I can find my best pipeline. I'll see it. Okay, what is my best pipeline? As you can see, so this is my best pipeline, which is the extra tree regressor. In this, it is saying that the criterion used is the mean square error, which I have defined. The maximum depth is none, maximum features, maximum samples, and all the different parameters. All the different parameters are there. So now what happens is, now what we have to predict our model. Okay, will just predict a model and store it. Okay, now if you want to see your predictions, we can see that what are the predictions of our model. Okay, see, let's see, this is the predictions. And now what we can do, that has our predictions are stored in a list. We can do the same, that we can check the accuracy of our model like we did in the previous sections. That is, we can create a distribution plot. This is the distribution plot which we created. Then we can also plot a scatter plot between y test and y predictions. Okay, which we can see that okay, how our predictions and the original values are distributed. As you can see, most of the values lie in the zero section and very few values lie in the negative section. Okay, which means that the prediction values are most likely to the equal or less than our actual value. Okay, so now this is our graph, that how it looks like. We reduce some of the dimensions here. We reduce the population size, we reduce the generation. That's why my model accuracy got affected. But if I would have used the population sizes 50 and the 5 generation, it would have been much better. Because of lack of time, I reduced it. You can experiment with it. You can see that with the best capacity, how it is performing. If you want to see in the numerical form the accuracy, this is my accuracy. So as you can see, my R square is drastically reduced because of the reason, because I reduced all of these things. Okay, so it did not perform much well because it only perform with a population size of 5, which is very less. it should have been minimum 50, and generations also must be 5, so that the model gets cross validated and fitted. So this was an introduction of TPOT library. As I told you, all the different parameters which are included, how you can tune them. You can use different parameters and see that okay, how your model is performing, and you can go to their website, check their website, and see that what all things you can do. You can do the pre-processing technique, you can build all other different projects with the help of this, and there are a lot of things to do. Okay, so you this notebook will be provided to you along with the data. Practice this and apply this knowledge on the basis of another projects also. Thank you.